Hello again. It's me, Axel, and welcome to another hour or so of Elm programming. I never know how long exactly it's going to take for me each session. But yeah, tonight's the night again. So what I want to look at tonight is actually revisit the functionality that I tried to implement last week already, and I wouldn't say I completely failed, but it was a medium success. So what I tried, what you're seeing now is what I tried to implement is that the pieces that drop from the top, that they actually rest on the bottom. And let's just quickly turn off notifications here, or not. But as you can see, especially the first part, if I just reload, it's the tile just falls one line too deep into the bottom. And I was not so happy also with the debugging techniques I showed. It was mostly console.log debugging, which is a fine approach if you have a good idea where the error is and you just want to narrow it in a bit. But it turned out I did not really succeed at really pinpointing where the error is. So, and I promised I'll show a bit about how to write tests in Elm, and I think it's a really good practice. And I was just lazy so far to show it. So as a kind of reward, I will revert my last commit where I had put my changes I crafted last week on the repository, and I would just try to implement the same functionality, but this time test driven. So before I get into the actual code, I show a bit how to set up tests with Elm. It's also super simple, of course, but it's a bit it doesn't ship with the compiler itself, with the Elm command. So I go a bit into detail why that's the case and what you need to do to get tests running for your local environment. Cool, so let's dive right in. So if I go into my console, just cancel my build script here, I am in my project directory. I already have it installed, the elm-test command. And before we follow those instructions, I quickly show how that works to get the command in the first place. And it's basically, I'll just open a new tab to search it. It's I've searched for elm-test. You will end up right away on the wrong repository, I think, because this has been archived and it has moved to a different repository. So now it lives here. And so there's a lot of introduction already on how to use it. I'm not sure if there are good instruction on how to install it actually. So the thing is, I don't know if the test already gave it away, but it's you can see it kind of from this here. So this, what we are referring to is the node test runner, the command line tool that I just demonstrated, the executable, the elm-test executable that we want to use to run the tests that we write with this Elm package. So actually probably this is the better place to visit to look for installation instructions. So that's here, it's a bit better. So it tells us right away, yes, use npm to install it. So that's the route that I went, and I don't want to go into detail how to use npm and how to install Node. There are plenty of tutorials out there about this on the internet that you can follow. I just share my personal preference is to use ndenv, which is a version manager. ndenv is better alive, blah, 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 whatever. So that's, but then again, I'm not a huge fan of JavaScript and the package system, Node. It's very cumbersome, at least in my opinion, compared to Elm. So I usually try to stay as far away as I can from that. But I had made good experience with Node-env because it allows to have multiple different Node versions installed in parallel, and with Node comes also npm, the package manager for the Node, which allows you to execute JavaScript outside of the browser, basically. So the Node runner, the Node test runner for Elm test is also based on Node.js. So yeah, I will also share this video on YouTube again. So if you get stuck somewhere, please write a comment there, and then I'm able to point you into some directions how to get the Elm test command installed. So maybe one of the questions is I also want to talk to some of the claims I made in my earlier videos that you might question when you're listening to this, is that with Elm everything comes in the box. So why is Elm test not part of the Elm executable? So like why do I have to call Elm test? Why can I not just call Elm test? Like there are so many nice things that come with the Elm tool. Why not Elm test? And the reason is that I think, or I don't know, I've not asked, but it's kind of my suspicion is like Elm, the command is really a tool to do one thing and one thing very well, and that is compiling Elm code into JavaScript code, and the Elm. So the Elm tests that we are going to write are obviously going to be Elm code, but to execute Elm code, or like with Elm we can translate this easily into JavaScript, but JavaScript does not natively execute on the command line, for example. So we need to kind of pull in this environment that allows us to execute this compiled JavaScript code, and it's like it's arguably outside of the scope of the Elm tool itself. So that's why we have this external, or I guess that was the motivation for Richard Feldman, I believe, who wrote the Elm test runner as a separate package that like next to it. Cool. So now that we have this, or once you have this installed, we have the binary, the command that we can just execute on the command line. And the nice thing is, as so many tools in the Elm environment or commands, it gives us really actionable help on what we have to do. So note, make sure you're running Elm test from the project's root directory, like that's our Tetris directory, that's the case. So to generate some initial tests to get things going, run Elm test in it. And it's really a pattern that I love, that kind of spiked with like the first big introduction to this to the industry that I saw was Rails, with this scaffolding mechanism that just generates the boilerplate to just give you an opinionated demonstration on where files are supposed to go in which two folders, and what a potential start to write things could be. So let's just execute this. That's also, I love this. Also, all the Elm tools and commands do this. They tell us what they are planning to do, and it's like, yes, I'm happy with this. Do this. Okay, success looks good. We can do a git status to see what actually happened, and we see like the Elm JSON got modified. So let's look at this. And yeah, it added the direct dependencies on the test library, and that pulled in the random package in the indirect dependencies. All good. And if we look into the test folder, what do we have there? There's an example Elm. So just going to open this in my Vim. Cool. Looks very brief. And now if we run Elm test again in our project root, let's see what happens. Yay! Test run incomplete because there's one to do remaining. Aha, awesome, to do. Cool, so let's just follow the instructions here. Copy that URL. Open new tab. And we end up in the Elm package documentation for the test package, which is great. So, and if you have experience, like this is nearly, I would say, an industry standard to organize your test in these hierarchical elements. So we have blogs that, and like this is kind of the DSL basically that comes with with the Elm test library to construct our test suite. Like we can have these nested describe blocks to group subgroups of tests, and ultimately the leaf nodes of this tree of describe blocks are the actual tests. So I don't know if those are a good start. Maybe we just, instead of just copying and then trying to see what's going on, we start with really explicitly. So the entrance, the entry node to a test is apparently a describe block. So we say describe, and I don't know, maybe we look up actually the signature for this function. What does it take? It takes a string and a list of tests, and it returns a test. Okay, cool. Let's see. Let's add a description here. My first test. And I know already it's a list, so I can already add the square brackets. And what is a test? Let's look up the signature for the test function. Takes a string and a function from identity to expectation. Cool. So let's just pop in a test here. Let's change this, my test block, test, first test, and an expectation. So the expectations, like, this is basically a cosmetic decision to write it this way, I guess. Like, that's just to indicate our test doesn't expect any parameters. Just a function that is going to be executed once our test is to be executed. So let's do this, and so expect equal. That's also probably, if you have used any test library in any other framework or language, that's probably looks familiar. So that's basically, I guess, equal is a function that returns an expectation. So we can just look this one up. Equal takes two values, returns an expectation. So cool. Let's do the simple thing. Expect equal 1, 2. And to my understanding, this should compile and execute. So that's also something, if we run elm test, it will automatically also recompile if necessary. So we see 2 is supposed to equal 1, which is not the case. So if we say 2, 2, boom, test run passed. I feel so accomplished now. No, just joking. Okay, I even have somebody on the stream. Hi, it's Quiddle. Nice to meet you. Yeah, so let's see how we can put that to use to actually progress our program. So let's just revisit where we were. Just reloading this problem. Stone drops, piece drops, but doesn't land in the right spot. Oh yeah, actually now that I wanted to revert my last commit first. Okay, so I'm going to quickly stash those changes. Then I'm going to bring up the commit hash for the last episode, and I'm going to git revert this hash. This reverts. Boom. And git stash pop to bring back our test changes. And I'm going to quickly compile this just to confirm that we should now be at the stage again where the piece just drops through. Oh, that's slow. Cool. In the meantime, I'll bring up the source code again. Okay, it's already there. And let's go down to the function. What was it called? Drop something with drop current piece. Yes, let's see where this is used. Gravity take, drop current piece. Okay, cool. let's go back again here. And yeah, so the piece falls through, or is reset actually by this little hack here to the first row again. So let's just undo this. It's compiling. So the plan I set out last week too, I think is still unchanged. The goal is when the piece hits the bottom, it actually sticks there. So, and the basic algorithm that I've chose to implement was like, first test if we can drop the piece, and if we can drop it, then we actually drop it, and if we cannot drop it because there's something under it, it could be either the bottom or a different piece, then we spawn a new piece. So let's try, like, and the difference in how I want to approach it this week is to be a bit more test driven. So before changing my production code, I want actually to write a test that expects a new piece of functionality, and only basically I want to try come up with a really small change, write the test for this, and then integrate it to my production code eventually. So I think the first most important thing the entry point for this algorithm that I just roughly described is to find out, can I drop the current piece? So let's go back to our test and describe. I will change the name for this block to so what's usually the syntax here to write this describe blocks? Oh, that was a bit too far. Describe the string module, la 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 la. Okay, so describe when gravity tick received test. I don't know. I can still rename those later on. So I just like say test if can drop current piece. So I'll change a bit the way this is formatted here just to make it a bit easier to read. And I think again, they use this neat little trick I used a couple of times already, where we replace the parentheses with this operator here. And I think that reads a bit more nicely as well. So I'm going to reformat this, see if that still pass, if this test still passes this way. That looks good. So now we can actually write our first test. So I want to introduce a new function that takes the current piece and the current board and returns a boolean if the current piece can be dropped. So how do we do this? Expect equal. I never know if the first one is the expected and the second parameter the actual, or the other way around. I don't know if they have opinions on this. Okay, doesn't matter really, it's easy to flip after all. So let's say can drop current piece, a board, and let's just say it's true. So this is ultimately the expectation that I want to assert. And now I have to set up all those expressions here because obviously they don't exist yet. So let's be super naive and say like, oh, can drop takes 2 parameters and returns true. Current piece. Okay, let's just types don't matter for now. Board. Just taking small steps. And what's also nice, I think the Elm test actually has a watch option. So yes, here on the way all the way to the bottom. Run tests on file change, so that lazy self that I'm being, I can just do this and it runs. And if we change this to false, for example, rebuilding, boom, failed, and I don't even have to submit the command again. So that's great. So first thing we'll do, we'll just import everything from our main module. Is it called main? I guess it's called main, yes. So that we have access to all our glorious types and tiles and whatnot. So first we want to make, I don't know, do we have an empty board function or something already? Empty board. Or maybe we just steal this definition for our tests. And this way, empty rerow board. We can also make just a smaller board, make empty row, and this way we can actually, like, it's a bit, if we, for example, have to debug a test scenario, it's easier to print out the format on the console if it only has 3 rows and 3 columns rather than it has the dimensions that we actually use in our production code. So make row, we're going to use this as well. Oh, actually, I mean, we can keep things a bit more dry if we actually parameter, move this function to the top level, make it a top level function, and column count. Use this parameter here, make empty row, and just hard code, whoops, with partial binding, hard code the 11 onto the make empty row. And yeah, make empty row. So blah 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 blah. Let's just be lazy and see if it compiles or if we have to change anything. Watching for changes. Hey, I changed something. Why does it not recompile? There we go. Cannot change range. That's correct. That's a function from the list package. So we're going to exposing range. Whoops. Okay. Bit sensitive to indentation. Cannot find a make empty row variable in the example. Make empty row. Ah yeah, because I forgot to expose everything that's coming from main. Now it should have access to the symbol. Map is unknown because it's also part of the map package. Cool. So our test is failing again. I mean, it's not testing anything really anyway. But we can now replace some of those expressions here. So empty board. Oh, actually, we can also... Well, let's actually do some cleanup here as well. We're going to parameterize our empty board function. Call it make empty board rows columns, and we can columns rows. Going to call it now make empty board, and I think our dimensions for the row, we already have a constant for that, board height, and like ultimately, okay, let's do the right thing, introduce board width while we're at it. Board width equals 11. Happy, happy, happy. Cannot find an empty board variable. That is correct. Empty board is called make empty board, and I said I want to have a 3-3. That's nice. Nice and small. And we have the next thing I want to do is come up with a sensible value for the current piece, and I think we have a dedicated data type for this. Current piece. There it is. Where is it defined? It's here. So we're just going to copy this as a template. What we have to construct. Position is a tuple XY coordinate, so let's say 1, 1. It's in the center of our 3x3 board, and the tiles are a list of position, and let's just create a very boring piece, which is just this one tile, basically the 0, 0, and the color obviously doesn't matter too much for our logic here. Those colons have to be replaced by equal signs. Cool. Does this check out? At least it's compiling, so that's good. So can drop, like we can actually develop, I don't know if that's, I'm just making things up as I go, as always. So I think I would just develop this function here locally in the test, and when I'm happy, or when I have to write more tests for this function, I can just move it up or eventually into the main module where it has to end up eventually to be useful to our production code. So can drop, what did I say? Says takes a piece and a board. So this will clash probably with this. Just call it empty board because that's what it is. Does it still compile? No. Board, yeah, because I renamed this to empty board. I mean, I would argue it should be able to drop it on the empty board because it's not in the center, so we can already adjust our test expectation. Now this probably passes because we're statically returning true here, but of course we do want to, well, actually I think the ultimate test driven the dogmatic way is to make a test green and then make one red first. So what I would say is, like, we actually want to test can drop piece on empty board, so that's good. If not at bottom, let's say it this way. So the next thing I would say to be able to be forced to extend our function definition would be to say cannot drop piece on empty board or any board if at bottom. So in this case, our position should be the lowest row, so that would be row 0. And we expect this to be false. And now we have a failing test again. So obviously we want to extend our only one function definition. So I'm going to drop this here. Remove it from our initial test. So now we have our test suite. When gravity tick received, we have one test that makes sure we can drop the piece when the board is empty and the piece is not at the bottom. We assert true. And we have a second one where we say like it should not be able to drop the piece on the board if that piece is at the bottom, where we assert false. That's the one that's currently failing. So TDD for the win. We're going to fix this test now. So, and I'm going to try to implement the same algorithm as last week, but just this time I'm trying to not make mistakes as I did eventually. If you're up for a riddle, then go to the video of last week's episode and try to spot the mistake. By now I figured it out, but I won't spoil. So yeah, so our position is now at the bottom row. Our tile is in the center bottom row. So this test should ultimately return false. So the easiest way, I would argue, to implement this is to be like piece. We can deconstruct piece to the position, and to be like let x, y. We're going to further destructure the position into this tuple and be like, okay, if y is larger than 0, then we can drop, I guess. So that should, yeah, we fixed another test. So so that's great. But it's also like, obviously it's more complicated than this. So now I'm wondering what's the next good red not passing test to write. Because we have like completely ignored the tiles. And that's okay as long as our piece is only constructed from one element. But I think I know what next type to write. If I would say if we have a piece that actually extends into in the y direction, so if cannot drop, if tile of piece would be outside of board. So that would mean like we have the simplest case to demonstrate this would be this. So we have a tile in our current piece that is actually not in the center, but below the center. And if we execute this test, it passes. So that's not good. Why does it pass? Cannot drop. Position is ah yeah, but because we were on the bottom already, so I have to move it one up again, and now it should be falling again. Okay, cool. Now we know what to fix, how to extend our functionality. So that means if we go to our current piece here, we also want to access the tiles. So now we actually have to the algorithm I wanted to construct last week is to take each of the tiles and translate it to the current position of the current piece. So let's call them translated tiles. And because it's an array, we have to map something over tiles. And the something, we know the something is taking one of the tiles. So it takes tx and ty and does something to it. So and when I said like translate it to the current position is here stored in the xy. It's really easy. The algorithm for that is just adding the x and the y of the current position to each of the tiles position. So we say tx plus x, dy plus y. And now that we know what to do, it's also easier to choose a name for the something. So I would call it translate to current pos, extra verbose, map this. So now we have for each of the tiles the positions, the absolute positions on the board, if we translate it to the actual position of the current piece. And like now we have to adapt this check to actually incorporate all of the tiles. So it's basically for each of the translated tiles, we have to check if they're below the board. So, and there is a special function in the list package to check if something is true for any of the elements in the list. So let's quickly go to the package documentation, list of the list package. And if I would give the order to a human to check whether any of the elements confirms to any certain condition, then like the keyword is the any here. And if we look up, indeed there is a function that's called any, and it determines if any element satisfy some test. So the any, so actually I can do this here. We will write list dot any, then the some condition, and we want to map this over the translated tiles. So what's the condition? The condition is again a function that takes a translated tile. So a translated tile is again just a position in this in the meaning here. So we can just reuse our tx ty identifiers for this. And the condition we want to check is if any of the translated tiles is in or below the bottom line of the board, then we want to return true. Or is it actually if we if we want to answer the can drop, the logic is actually inverted. Like we only want to return true if all of the tiles are not on the bottom line or lower. So, but luckily the solution for that is not far. There's another function called all, which basically does the inverse, checks if all elements satisfy some test. So, and the test, like again, let's just write it here, all instead of any. And the condition is that ty is larger than 0. So let's, now that we know below it has to be greater than 0, we can also find a better name for condition. So let's just call it above bottom. So let's see if that makes sense. Can drop returns true if all translated tiles are above bottom. So that in my head that makes sense. Let's see. Woohoo! It passes. I don't practice TDD often, but every time I do, it's just incredible how satisfying the feeling it is to make a test pass. All right. That's good. That's good stuff. So now we can have multiple tiles for a piece, and it will determine if it can drop it. So I think maybe we leave it for that function. And I think So let's see how we would integrate this into our production code. Drop current piece, that's the function. So I would say I would like to write if can drop current piece on, where's our board? Oh, we can just deconstruct it here as well. If can drop board, oh, then goes here. That's where I want to put the else. Cool. So I would say, like, if we can drop, then we drop. Otherwise, we just don't do anything at all for now. Does this compile? It does not try. I cannot. Yeah, because our can drop function is still defined in our test function here. So I'm just going to steal this from the test and paste it here in our main module. Test still running. That's great. Maybe we actually go through the hassle of writing a signature. So it takes a current piece and it takes a board and returns a boolean. Yeah, again, same mistake as last week. It's just called bool in Elm. Compiling again, tests are running. I guess it should have compiled already. Let's see if it has the desired effect. Can still move the tile. Yeah, maybe it has to be recompiled actually. Compiled without errors. Let's reload. It's a really patience challenge at this speed. Maybe I should reduce the interval. And it rests. Isn't that awesome? So at least we fixed that bug, but I already implemented a bit more functionality. Just quickly turn on the light. All right, so now I think the next important step would be to actually generate a new tile once we cannot drop the other tile. And we already have created a natural place for this to handle. So basically the else branch of the can drop here should be to create a new piece. And we can steal some code from our initialization code. Let's try to find the init function here. So, no, actually we have to do something first, because now the current piece is on the bottom here, but it's still the current piece. So to be able to create a new current piece, we have to do actually two things. We have to bake in the last current piece that cannot be dropped anymore into the board, and then we can generate a new current piece at the top of the board. So, and I thought I had a function for this already as well in place. Place piece on board, basically. Yeah. So that's great. I guess we can just use it. So when we cannot drop the piece, we do two things. We say board equals place piece on board, current piece board, and we generate a new current piece, and that's the one I wanted to steal from the init declaration or init function. Okay, tiles, position, board height, great. And I think we wanted to spawn a J piece. And I have a syntax error because I forgot the comma here. And then usually I think it's nicer to have the... I really love this way to format lists and objects. Reads, in my opinion, so much nicer than having the comma at the end of the line, but that's clearly a flame war I don't want to start. Compiled without errors, that's great. Oh, and I have to reduce this timeout. So let's make it 300 milliseconds. Reload, boom, that's more like it. Yes, going to put the L next to it. So that's really great. But now here's this. It doesn't respect the other tiles. So I would argue that's the next thing to implement. Yeah, we still have a bit of time to do that. So I just go back to our test suite, and I would say actually this block here is kind of more for the can drop function. Can drop, let's call it this. So let's see if we can create a proper test that doesn't pass, that expresses this. So I'm going to just copy the last step, cannot drop if tile of piece would collide with other tile. Let's put it this way. So so now that first we have to create a condition or the outgoing situation, incoming situation that expresses the test scenario. So instead of the empty board, we have a board with a tile. So we do make the empty board, but we will place a tile on this. So what was it called? The function we just used, place piece on board. And it's, let's call it an already placed piece. And what, it's a current piece again. Okay, so that's good. So we can just copy this. Position is in the lowest row. So what I want to create is we are still operating on this little 3x3 board, and I want to place one tile in the center of the bottom row, and then I want to try to drop a current piece that has one tile that is just above it on top of this, and I'm expecting this to not work or to return false, and it's going to not work as we saw. So the already placed piece has the position column 1, bottom row, and we are going to use our very simple tile here again. Let's just, for the fun of it, make it red. And the current piece that we want to drop is also going to be really simple. It's going to be on the on the center row, in the center column. So our board with the tile will place the already placed tile on the empty board, and then we expect can drop with the current board, with the current piece on the board with the tile. Board with the tile to be false. Let's execute our tests. And it's false expected to equal true. So, and it's the right test. Cannot drop if a tile of piece would collide with other tiles. So that's perfect. So we have our failing test. So I think it's time to look at our can drop implementation. So I think it's okay to say, let's just hardcode stay with this condition if, oh no, let's actually, how do we do this? How do we do this? I'm wondering if this condition, this function call with all still serves this, or if it's a too specific a case. Translated tile. Yeah, I think we have to, the above bottom condition is just not precise anymore. So it's not above bottom, it's above bottom and doesn't collide with any of the existing fields. So I'll just rename this to condition because I'm not really sure what it will look like in the end, and then we can, whoops, then we can rename it again once we have a better understanding. So what we want to do is for this tuple, like for this position, to check if it's empty on this board, basically. So if I would say if ty is smaller or equal 0, then we can directly return false. Yeah, that makes sense. And in the else case, like that's the complicated case, when the tile is somewhere in the middle of our board, we have to check if if we would drop this tile by 1, if this position is free. So I would actually say translate to current pos. Like for now, we only calculate the positions that the tile takes, that the tiles take in the current position of the current piece. But what we want to try when we drop it is actually if like we pretend to drop it and look if the then translated positions are still free. So we actually have to add 1 in here, I believe. Oh yeah, and now our tests will really serve us well to make sure we didn't break the stuff that already worked. So that's plus, definitely. So now we have calculated the positions of all the single tiles of our piece 1 position lower. And it's arguable that if it's below 0, well, we actually have to remove the equal sign because it's okay to drop it into the bottom row. It's only cannot be dropped if any of the tiles would be below the bottom row. So that was the first trap avoided, I would say. But if we're below, then we have to basically look up the position of the translated tile and see if it's empty on the board. So I don't know if we have an isEmpty function or something like this already. We have empty, make empty row. I'm just string searching row view. No, we don't have anything with that. So I would say we make an isEmpty predicate here, empty. It takes a tile position and returns true or false. So what we want to do is actually look up the field on a board, and maybe we actually maybe I mean, in the ultimate test-driven approach, we would now write tests for this function. but given that I have been talking already for 55 minutes, I think I will again try to take a shortcut, and I hope it doesn't bite me as last week. We will just try to write a lookup function here in place, and it takes a position and a board, and it should return the tile that is in this row and this column of the board. So let's look at our definition of the board type. Type board, no, it's an alias, I guess. Type alias board. It has a list of rows, so let's say rows. So we have the list of row. The first row is the row 0, then comes row 1, no surprises. So if we have a y coordinate of, let's say, 3, then we basically, in our lookup, we can ignore the first 2 rows. And to get rid of the first 2 rows, there's a function, 2 elements in an array. There's a function called drop. And it takes how many elements are supposed to be dropped, and it takes the array, or the list, to be more precise. So list drop 2 will return, takes the original list and just drops the first 2 elements and returns us the rest of the list. So that means if we have a coordinate 3, 3, then after list we have a list of rows, and the first list after the drop is the one that we want to look in for. So let's call this row. And okay, I'll just write out the algorithm. I mean, we went over this last week already, that the drop actually returns a maybe row. So I'm just going to prefix this here, because if is it actually true? Yeah. Oh no, that's not true. That's the head that returns. So this is, yeah, and like what I actually wanted to do is list head. That's the thing, the construct that we used last week. So I'm dropping the rows I can ignore, and then I'm taking the first. And this does, since I can always pass in an empty list, this can return a nothing. So lookup, yeah, I would say lookup can also return nothing. So we can say case mb row of nothing. Then we certainly don't find this field, so we can just return nothing if I can type it. If it's a row, then we do the same algorithm with the row, where we are just like list head list drop, and of course that's not hard-coded 2, but a ty tx row dot, I don't know, I see a list of row. And what is the definition of the row type? Row, okay, row is an algebraic data type with columns. Or we can just call it fields. That's a bit closer to the type name. And then we just fields. So that means if I'm trying to access something out of bounds here, a row or a column, then I'll just get a nothing. And I mean, it's easy also to implement a out of bounds check for, I don't even know what happens if I drop -1. But anyway, I think we can just, for the sake of progress, move a bit faster. So if is empty means basically we want to look up a position on the current board. And if that is just empty, then the board at this position is empty. And now we can finally weave that into our condition. So can drop if is empty again. Can just use pos here as well. Is empty pos. And the condition, I would say, can place maybe this position. Let's see. Oh, I'm so curious about our tests. TY247 is, whoops, 247. Ah, yeah, okay. TX as pos. Ooh, lots of red tests. Cannot drop piece. Okay, our first test is failing. It's expected. Oh, it's not the first one, but so let's fix our tests again before we try to actually use it in the game. Cannot drop piece if at bottom. Which test is this? So the piece is at the bottom as the test says, and it still returns true. So why is that the case? I would love to know if we can execute a single test. That's something that I should have tried to look up before. Can we run a single test? Yeah, I think we can just, oh no, we can run a single test suite. I don't know. Only, ha, I knew it. So we have one thing, so that's good. Let's try this out. Instead of test, we can use the only function, and I would hope that it would only run this test, but it doesn't work. Only, because only has to be fed into a describe bot block. So I have to say only describe foo and then pass in the test. I mean, that's not super convenient, I have to say. Maybe I just cheat my way around this. Oh no, it works. So now we only have execute the one failing test, so it's not too bad. And that has advantage. Now I can litter my implementation with logging code again. So let's see if our translated tiles actually are correct. So we can just put in debug.log, translated tile, translated tiles, save that. And now that's the nice thing. The console log basically not just works in the browser in Elm, but if we use it in the test, then we also get this output on the console. So we see translated tile is 1-1. And I think that's already where the mistake is, because we have a tile and it should be it should be at the -1 because we are dropping it. And I think my mistake here is that I wrote +1 instead of -1, and it's like I forgot that we increase row numbers. No, 0 is the lowest number, so each row going up is 1 higher. So let's see. Now the position is correct, but the test is still returning true, which is not the right thing. So if all can place translated tile. So this expression is true. I don't need to debug this, but the question is why? Because ty is definitely smaller than 0 from the translated tiles. So I'm a bit confused. Let's see if this is the correct test. Cannot drop piece if on bottom. That's correct. Okay, going to sprinkle some more debugging onto this. Debug.log can place. And let's just log the Y position for this one. Can place is 1. Why is it not -1? Ah, because I switched X and Y here. Okay, okay. It's not so bad. And now it's working again. And it's yellow and it does not tell us that it's passing because test only was used, which is correctly indicating or identifying that I did some test mingling there just for some partial debugging. So let's undo those things. We can just do undo, whoops. And all our tests are passing. Isn't that wonderful? For some reason my debug statements are still in there because I only saved the test file. Cool. So let's kill the test watcher and compile the baby. Compiled. Reload. And now I know that's a mistake I already made last week. I spawn new tiles outside the board, so that's why it cannot drop them. So let's change this. Whoops. Init board height +2. And we need to do this here as well. Y2 just to be safe. Still doesn't work. I don't know why. I'm confused. Because again it's plus and minus and not plus. Compiles. There we go. Our piece. Boom, spawns a new piece. Yes! Success! Cool. I'm happy. Oh, didn't manage. I want to swoop it under it. Cool. So yes, that definitely fits better than what I finished with last week. I also didn't write the show notes for last week because I was just too busy. And given that I tackled basically the same problem twice, I think I'll just write a combined blog post for the last 2 episodes with a few references to the test library and so on. And then next week, maybe, I think the next pressing issue is to be able to rotate tiles. So that's going to be a fun one as well. Thanks for staying with me, for the people who joined the Twitch stream, and looking forward to talk to you next week. Have a nice one.